All engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
advances,
Questions. Research.
technology.
Unbelievable.
Without further ado,
this is The Naked Scientists.
Hello and welcome to the show where we bring you the latest breakthroughs in science, technology and medicine. I'm Harry Lewis. In this week's show, we'll be considering why grandparents are happier than moody teens, trying to identify the pigmentation in dinosaur feathers, and stripping the Hadron Collider down to size. It's a big task, in an attempt to discover why it's had so much media attention this week. And later on...
More so for my morning cup of coffee. I really look forward to my first one. I get very excited to have my first cup of coffee. I get really a bit peeved if I get disturbed in my little ritual of having my cup of coffee.
Do you like your caffeinated beverages as much as my father? If the answer is yes, then you might not like the ominous forecast it's received from experts. The future of coffee, coming up.
The Naked Scientists podcast is powered by ukfast.co.uk.
First up, oxytocin is the brain's hug hormone. It helps us bond with our babies and lovers and makes us more inclined to trust others. Interestingly, as Claremont Graduate University's Paul Zak has been showing, the older we get, the more of it we make. And this, he speculates, means we tend to be happier with our lot as we grow older. It also means we feel a stronger urge to connect with others. Bearing this in mind, our own James Titko experienced a sudden urge to call someone very special to him.
Hello?
Hi, Grandma. How are you?
Oh, I'm all right.
It's James.
I know, James. How are you?
I just wanted to call to see how you were.
Oh, it's very nice of you, James. Thank you very much.
No worries at all.
I'm not too bad, but you don't sound like James.
Why'd you say that? It'll be because I'm on the studio microphone, probably. Paul Zak and his team have been showing that as you age, your brain trains itself to release more oxytocin, and through further reinforcement from positive social interactions, you have further desire for these behaviours. I asked him how they managed to show this.
Well, many neuroactive chemicals like testosterone and estrogen decline with age. We want to see what the release of oxytocin would do, so we measured the change in oxytocin in blood after a short video in people aged 18 to 99, and then related that change in oxytocin to a variety of behaviors to understand not only is the release changing with age, but is it affecting behavior? And in fact, we found that the older people were, the more oxytocin they released and the more helping behaviors they engaged in.
You said you were showing a video to 100 people. What exactly was the video, and how did you know that it was a sort of an oxytocin inducer?
If I use a video, this is a video we've studied extensively in my lab for the last 15 years, and many other people now have used it as well. It's a really consistent way to induce the brain to make oxytocin. There's a video of a father and his 2-year-old son. The son's dying of brain cancer. It's super sad. It's very sweet and warm. And then we gave people, in addition, a chance, since we were torturing them by drawing their blood, we paid them. We gave them a chance to donate some of the earnings to the research hospital that had produced the video. But then we went further. But we also looked at the change in oxytocin related to previous pro-social behaviors. In this case, in the last year, how much people had donated money, time, and goods to charity. And it's the first time we've shown the acute production of oxytocin is related to retrospective pro-social behaviors. And that's important because it tells us that the change in oxytocin may in fact be tuning up based on your previous history of behavior. So in other words, you can train your brain to release more oxytocin by engaging in more helping behaviors. So there's a key takeaway here for younger people or people of any age, which is if you have a habit of connecting to others, of helping others, then you're training yourself potentially to be a better oxytocin releaser. The more you release oxytocin, the greater satisfaction in life people have.
We've just gone past Easter and Passover, and Ramadan's still ongoing. So do you find that your work is sort of consistent with these religious traditions?
think religious traditions have survived many for thousands of years because there's some ancient wisdom captured by them. And what we're finding here is the underlying neurologic basis for that ancient wisdom, which is we can live more fulfilled, happier, more satisfied lives by being in service to others. Oxytocin does a couple of interesting things in the brain. It reduces physiologic stress. So that means we have potentially better cardiovascular fitness. It also improves the immune system. So by serving others, by connecting to others, we're actually improving our own mental health, but physical health as well.
You hear that now, James?
I do
I
hear
could
you.
smack your bottom. Yet,
You could.
I could, James.
Only if I deserved it, I hope.
So goodbye then, James. Behave yourself now.
I will do. Have a nice day.
God bless, James. Bye-bye, dear.
Wasn't that really sweet? James Titko's grandmother there. And James was also talking to Paul Zak. That study was published in the journal Frontiers in Behavioral Neuroscience. Now, the Inca people appeared in Peru around 800 years ago. They notoriously practiced human sacrifices high in the mountains. In recent years, the bodies of some of these children have been discovered, like in 1995. And owing to the extremely low temperatures and dry air, they've all been really well preserved. So well preserved, in fact, that things they were eating and drinking at the time they died have been preserved too. That includes plants with known medical qualities, including agents that give relief against altitude sickness and substances that cause euphoria and relaxation. Speaking with me from the University of Warsaw is Dagmara Soha.
Inca sacrificed many things to God, including the textiles, food, and the object that they value and think that they were precious, like the gold, silver objects, but also spondylus shells, and they were trade them for long distance to have them and sacrifice them for the god because they were pressure them even more than gold or silver.
Is this something that would happen on an annual basis, or how frequent would a ritual like this occur?
Incas make this sacrifice when something important happened in the Inca Empire. So when the new heir of the throne have been born, or the Inca ruler was sick or died. Also, they make it for the important places in their empire, like for the high mountains or pilgrim center. And then they make it also when something important happened, like there was earthquake or eruption of the volcano.
And you managed to get your hands on a couple of these, I suppose you'd call victims. It must be very exciting to get something that's so precious. So what can you do with it? What can you find out when you get a sample from one of these victims?
So we know from previous research that Incas give to the children and young women leaves of the coca to masticate. And some of the mummies still have this rest of the leaves inside the mouth. Chewing of them help with altitude sickness, which is quite often in high Andes. But we also want to check if Inca gives something else to this victim. And the second was the ayahuasca beverage. In this case, we actually find the trace of consumption of lianas that called Banserotopis capi, and that they are growing natural in Amazonia forest, and they are a main component of this ayahuasca beverage.
That particular plant in the beverage, what purpose could it serve being given to the victims at the end of the ritual?
Generally, the modern ayahuasca is contained from two plants. One of them is this lian that I mentioned, Banserotopis capi, and the active alkaloid is harmine. The most important property of this plant is antidepressive, and today the harmine is also used for anti-addictive treatments.
This must be one of the first examples of humans using antidepressants.
Actually, it is. We have some trace of the consumption of harmine in the previous studies from the mummies from the regular descent, but we didn't know in what purpose it was given. And here we have the clear chronological information that for the Incas, it was important the good mood of the victims. So giving them antidepressive plant could be clearly the intention for this kind of purpose. And it's also the first evidence for using by Incas antidepressive plants, and also probably the oldest case known to date.
And that paper really was fantastic to read. Dagmara Sohar and her research was published in the journal Nature.
From baffling British weather
sideways spines of the vertebrae coming off here
to looking at a cheetah from the inside out, games making their way to the clinic, and what to eat in your garden. The Naked Scientists in Short podcasts bring you a top-up of short, compelling science stories. Listen and download for free at nakedscientist.com/short or subscribe to Naked Specials on iTunes.
Coming up later on the show, 3D printing and the difficult future facing coffee. Before that, fluffy feathers. It's probably not what springs to mind when thinking about dinosaurs, but based on fossil records, at least some dinosaurs are thought to have had plumage, and most likely colourful plumage too. Now, scientists think we can add another prehistoric creature to the feathered list. It's pterosaurs. A specimen of one of these flying reptiles shows feather-like sprays issuing from its head, and by looking at very high magnification, the University of Cork's Maria McNamara has been able to pick out structures called melanosomes. That would have held the melanin pigment that gives skin and the feather of modern birds their colour schemes. She took Julia Raby through the findings.
Pterosaurs were flying reptiles. They ruled the air at the same time that dinosaurs were roaming the land, and they had long, leathery wings, short legs, and some had enormous head crests.
And when I think of flying, what comes to my mind is feathers. So did these reptiles have feathers?
That is the million-dollar question. For many years, we've known that pterosaurs had an outer coat of some kind of fluffy stuff. Then we rocked the boat a little bit a few years ago when we reported that we had found branched feathers in 2 juvenile pterosaurs from China. And the style of branching in those feathers was not quite like that of modern birds. The feathers were actually branched in little tufts, but now we found a pterosaur from a different group, and the style of branching in this pterosaur head crest is much more like the style of branching we see in modern birds, because the branches are successive. They're the whole way along the feather shaft. So feathery pterosaurs are a thing.
From your work, did you find out anything else about the properties of this feathery coat?
Where things got really exciting was where we put the feather samples under the electron microscope, and we found that they preserve little granules of the pigment melanin. What was very unexpected was the fact that the melanosomes have different shapes in different feathers. So the simple unbranched feathers have real sausage-shaped melanosomes, and the branched feathers have shorter egg-like melanosomes. This is really exciting because modern birds do the same thing, and they do it to make different colours.
How does the shape of these melanosomes impact feather colour?
Depending on the melanosome shape, you can produce, for instance, orange, reddish, ginger colours. They are produced by ball-shaped melanosomes, whereas blacks and dark browns are produced by sausage-shaped melanosomes. This very strongly suggests that those different feathers had different colours.
If these animals had coloured feathers, what colours do we think these might have been?
It's difficult to give a precise hue because our current models which we're using to infer colour aren't as accurate as we'd like, especially when it comes to trying to figure out how other pigments might influence the colour. Just finding melanosomes doesn't necessarily mean that your feathers were black or brown, but that long bone that sticks out from the back of the pterosaur head would have had these black unbranched feathers near the head, and then out near the tip it would have had these paler branched feathers. That's our best guess for now.
If pterosaurs had these, coloured pigmented feathers, what do we think they might have been used for?
To answer that question, we really would need to get a good handle on the precise colour and on the colour pattern. But because we only have the head, we can't really tell what colour patterns they had. It just tells us that the importance of visual signalling, of sending signals to other animals, maybe about your fitness, or maybe to attract mates, or maybe for camouflage, how important this is for survival. I guess, we just have to find some pterosaur specimens with feathers distributed over the whole body and start looking at the patterning.
I guess you do, Maria. That's Maria McNamara, and her work was also published this week in Nature. Now, you may have heard that the Hadron Collider has received a recent makeover. This is the Large Particle Accelerator over in Geneva. Its circumference is a whopping 27 kilometres. It's so large that it straddles France and Switzerland. And here to tell us a bit more about the revamp is Stephen Abel, Professor of Mathematical and Theoretical Particle Physics at the University of Durham. Stephen, maybe you can take us back a little bit and just give us a quick refresher on what research actually takes place at CERN.
So the LHC is a proton-proton collider. So what we do is we accelerate protons to extremely high energies, and we collide them together, and we sort of pick over their wreckage, basically, in order to hope to find things that we don't expect to find, maybe find new things. Since it began sort of maybe 2 decades ago, it's been just sort of confirming what we think about the early universe, the nature of matter, and sort of reproducing things from the early universe that we expect.
And at the moment, we've seen in the news that there's been these improvements made to the structure. What are those improvements?
It's a kind of incremental. It's increasing its luminosity, as we call it. So it's the intensity of beam. So it's the number of collisions. We want to increase them as much as we can in order to get more data, basically. So we're always trying to get as much data as possible, because the things we're trying to test and the things we're trying to look for are extremely rare. And in order to see those things, to test them, you have to have a huge number of collisions.
With this coming in, scientists are getting quite excited. What are they excited about finding?
I mean, there wouldn't normally be so much excitement with this sort of upgrade, I don't think. But it's because at the moment, it seems as if we're on the kind of cusp of finding something completely new. So up to now, we've had something called the standard model, really since the early 70s. That model has described everything to a sort of ridiculously good extent. It's one of the most tested models imaginable.
And that's the particles, is it, in the standard model? It's a list of kind of what we would see.
That's right. So the standard model contains within it, I mean, as well as the fundamental forces, of which so far there are 4. 3 of them are described in the standard model. Gravity doesn't appear there. Plus, then there are matter particles. So the matter particles are quarks. And there are 6 flavors of quarks, so they all kind of have different properties. And 6 flavors of leptons. Leptons are like electrons. Inside a proton, there will be 3 quarks.
And is it thought that the experiments that could come out of CERN at the moment, then, it might challenge this kind of well-solidified standard theory?
That's right. Some of the wreckage from these collisions, one of the interesting ones is when a B quark, so a B quark is quite a heavy quark, occasionally you produce them, so maybe 1 in a million collisions will produce a B quark which decays in a certain way to, say, 2 electrons or 2 muons plus something which is called a strange quark. Those particular sorts of decays are showing things which we do not expect in the standard model. So they're showing that the muons are behaving differently from the leptons. So that's called a lepton non-universality, and that is not an ingredient of the standard model. So that's a complete surprise. And the reason people are excited, so if you look at one of these things, it wouldn't be so out of kilter, but we're seeing that there's quite a few of them which are all pointing in the same direction. So what people are hoping for in the next run is that we're going to get enough data that we're going to be able to say that, you know, that this is now something which is definitely not the standard model. So we're definitely seeing something new. And we can throw away the standard model, finally.
It feels like it could be a massive shake-up for particle physics.
It'll sort of be the only game in town for a while. Everyone will have to think about what on earth is going on. Where does it fit into a larger theory? And, you know, eventually it could have some sort of ramifications for example, fifth forces is a possibility that there's an additional force, or new particles could be producing this effect called leptoquarks. So that's another idea. And so it could ultimately be the start of changing all our perceptions about how everything is arranged.
Stephen, are you expecting to see this come to fruition over the next year or 2?
So you're now asking me to place bets. What I think is that we're close enough that it will, in this run, it will be confirmed in a sort of technical sense.
Thanks there to Stephen Abel. That was some pretty complicated physics. but it was beautifully explained. 3D printing, or additive manufacturing, has revolutionised engineering. With it, we can make and test designs of bespoke objects quickly and cheaply. Rolls-Royce recently even began printing hard-to-manufacture parts for some of their jet engines. But there are limitations. You have to build up your object layer by layer, which means some structures are still tricky to make, like one object that needs to be inside another object, for instance. Now, scientists have come up with a clever solution, both literally and metaphorically. They have a light-sensitive fluid that sets when light of a certain colour shines on it. But surely whenever the light shines through, you get a line of set material. I hear you cry. No, as Stanford's Tracy Schleimer explains to Robert Spencer, she's come up with a material that contains particles that convert a different inactive colour of light to the critical colour that sets the material. This means you can control the setting process and make objects inside objects, like the miniature boat she showed Robert.
Tracy, I'm looking at this picture and it looks like something out of The Office. There's this small item in a piece of jelly. What is it? What are we looking at?
It is not a joke from Dwight Schrute. It is a boat that I have printed and used light to pattern on the inside of the jelly, or jello, as we would call it in the States.
So this is a 3D printed boat that you've put into this solution. How did it get there?
What I did is I used a laser, focused down, and then that's absorbed by a molecule in the jello that allows for me to print Benchy.
Okay, so it's one of these curing resins, like people might be familiar from nail gels or dental work.
Yes, except we made it ourselves.
So it needs light in order to set.
Correct, and a very specific wavelength of light as well. So when I shine the red light at it, it doesn't necessarily work right away. We have to have a certain power density to generate this blue light.
So why can't you just shine blue light into it?
So when you shine blue light at it, that blue light gets absorbed at the surface. So I wouldn't have been able to print Benchy deep within that vat of jello. I would have only been able to print Benchy just from the surface, and I would have had to move the resin up over time.
We should probably clarify, Benchy is the little boat in there.
Benchy is the adorable little boat, yes.
You've managed to print this by focusing this blue light inside the resin, but you say you can't just shine blue light because then it sort of prints at the surface. So how did you get the blue light into the resin if you can't shine blue light onto the resin?
Yeah, we generate that blue light in situ or inside of that resin. And so we have some very special molecules that can convert red light into blue light. And we can do that really quite precisely.
Does that mean that you've imbued this resin with the special molecules that you've designed? How does that work?
Yeah. So what we do is we have these special molecules and we encapsulate them. If you're familiar with the drink boba, it's like we have these tiny little nanometer size boba beads. And they're so small that you can't see them directly with your eyes. So the resin, the jelly still looks clear, but we have those embedded in the resin. And so we can generate that blue light by focusing the red light really well on those boba beads. And that's how we're able to do it.
So you focus this red light and then suddenly there's like this flash of blue light at the point where all the focusing comes together.
Yes, it's really cool. And we can use an LED, and that's much lower power than using a laser.
We've seen similar kinds of technologies before, similar light-cured manufacturing. What sets this apart from the existing things that you can buy off the shelf?
Off the shelf, if you have a spare couple million US dollars, you can buy a nanoscribe, and you're going to be able to get really, really good resolution, but you're stuck with really, really tiny volumes. We can print 1,000 times larger than that. We can print at much lower powers. We can print faster. And to be fair, our technology isn't commercially available yet.
And where else is it going, this ability to take lower frequency light and upscale it to higher frequency light? Does that have any uses beyond making cute boats?
Yes, but it is a huge challenge. How do we get high energy light precisely where we need it? Imaging, optogenetics, drug delivery, where you have to use low energy light to go beyond the surface of your skin. So we have these, maybe a drug we want to deliver, but oh man, we need yellow light to kind of trigger it to release in the body. Well, how can we generate that high energy light beneath the surface? Well, we can use these up conversion nanocapsules that we've developed.
Tracy Schleimer speaking with Robert Spencer. That work was published in the journal Nature.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
For the rest of the show, we're talking about your cup of joe. We're going to be discussing how much we know about it before turning our eye to the future. And this chat, it's going to be fully inclusive. We're not going to be snobbish about it. So it doesn't matter if you like it black, strong, instant, Peruvian, or even served ice cold. So from the ground up, what is coffee? Well, here's Luigi Leone at Cambridge University Botanic Garden.
So the caffeine facts
What have we got in front of us?
We have Coffea arabica, which is one of the 2 species used for coffee production.
Sat in front of us is a very leafy little shrub.
Well, the specimens we have is quite small, but it usually becomes 4 meters, 5 meters high. And it has these leaves which have quite wavy margins with sort of ridges that develop from the center of the leaf, and this very long tip, which is used by the plant to shed all the excessive water coming from the humid atmosphere of the tropical rainforest from which this plant comes from.
When the plant fruits, it produces coffee berries. They turn from a dark green to an off-yellow and finally a scarlet red, indicating that they're ripe for the picking. And once that fruit is removed, well, there you have it. You're left with the coffee bean. Now, at The Naked Scientists, we've noticed a rise in supermarket coffee prices in recent months. And that merits investigation.
Oh. Okay, let's give him a call.
If we're going to talk about coffee, I should start by introducing you to the biggest coffee drinker that I know.
Oh, thanks.
I mean, that's not wrong to say, is it? That's pretty accurate.
Yeah, no, it's not wrong to say. I do love a coffee.
How many coffees do you have a day?
4 or 6.
4 or 6? I thought you cut it down to 1.
No, I've gone back up again now.
4 or 6?
I cut back for a little while, for 2 or 3 months, but 4's been pretty standard for me.
Have you noticed a change in the price of it over the years?
Yeah. The coffees I get, what they do, they cut down the pods. The price is staying the same. But where you used to buy, for example, 16 pods for £3.50, some of the manufacturers now are doing 12 for £3.50. And there's one that still does 16 at the moment, which I'm sticking with. But I do know that they are about to go up again because there's a shortage of coffee beans coming out of Brazil because of the bad harvest. So I think the coffee...
And that's right. This year's coffee production in Brazil is expected to be down 23% from 2020 due to frosts and droughts. And experts predict that it's going to get even more difficult to forecast coffee production in Brazil due to increased flooding. I'm also willing to say that my dad is right on record because I checked his facts with someone who knows.
Hi, my name is James Hoffman. I've worked in coffee for nearly 20 years now. I've started a coffee company. I've written a book called The World Atlas of Coffee, and I also make YouTube videos all about coffee too.
James tells me that coffee prices have been on the rise for years.
Oh, there's definitely been a rise in price. Coffee is definitely suffering at the hands of the challenges of global logistics right now. And I think just the cost of doing business, say in the UK, has gone up. Wages have gone up. Everything's gone up. As well as people trying to build sustainable businesses after one of the most difficult periods of trading in living memory.
Feels like a brunt that quite a lot of people are going to have to bear, right? Because there's an awful lot of us in the UK that like coffee.
Yeah, we're kind of a medium coffee drinking country. We're not like a hardcore coffee drinking country like the Scandinavians. They drink something like 4 times as much coffee per capita as we do. And we're about half that of the Americans or the Italians. So we're like a reasonable coffee drinking country, but we're not like super serious.
What is it about it that we love so much? What keeps us coming back for more?
I don't think we can deny caffeine remains the primary driver of coffee consumption. But I think a lot of people have made a leap from having a very sort of transactional relationship with caffeine, where I will drink this thing and I will feel alert, awake, productive, whatever it's going to be, into I will do that for those things, but I'll have a good time along the way. And I think people have seen coffee now as an opportunity for deliciousness. I can, get the chemical hit in a really pleasant, enjoyable, interesting way. And I think that's really changed our relationship with it.
And I'm sure you've seen it. There definitely has been a boom in artisan coffee production. I've driven just outside Cambridge to what must be this city's favourite coffee house. It's called Hot Numbers. I'm going to meet Simon and Emily. It's here that they dream up their aromatic concoctions, which are made purely from Arabica coffee. That's one of the 2 most commonly consumed species. I think we want to know how it's possible in this day and age to get so many products from one single type of bean.
Let's roast some coffee.
Let's roast some coffee.
Yeah. Our Brazil here. We got 12 kilos of it. Now, obviously they've had all the cherries, etc. removed, so see here, Harry, it smells kind of grassy, like sort of straw.
The roasting process plays a pivotal role in the flavour of the final product. And Simon's let us join him for the 9 to 12 minutes that it takes.
So now we're going to drop the coffee in. The drum is preheated, it's a big cast iron drum. You drop the mass of coffee, which instantly kind of cools the temperature on the probe, and then it slowly heats up, so the roast profile will look like a tick. And once we get a profile we like, we can dramatically change the taste of this coffee, you see. The airflow, the temperature and the time all have dramatic effects on the coffee, and also you can get an incredible amount of variety from different countries and the way they grow their coffee, the altitude they have and the way they farm them, the soil. So yeah, absolutely.
Well, let's pop over to the shelf and have a look. Is that all right?
Yeah.
Over at the shelf, there's all of the Hot Numbers coffees, and they've got a huge variety of flavours. There's also Emily, and she has a surprise in store for me.
So we are going to test some of the coffees that we've got here. We're going to start off with the Roger Chilcombe, which is a Peruvian coffee. So this is grown at medium altitudes above sea level, so it's about 1,900 to 2,000 metres above sea level. I won't tell you what flavours come out of this. If we have a go and see what you can figure out.
Needless to say, I was absolutely useless.
For me, it's more like grapefruit. So it hits the sides of my tongue, it coats my mouth, and I can really get some grapefruit out of this one.
Maybe for the naive tongue of mine, we could compare it to something else.
Absolutely. This is actually my favourite coffee.
Okay.
It's the El Diviso, so this is a Colombian coffee. And it's grown in varying altitudes, so this is slightly lower than the first one. So we should be getting a lot of different flavours that come through in this coffee.
Cheers.
Cheers.
Up on the wall, Simon and Emily have this Specialty Coffee Association's flavour wheel. It looks like a chemistry textbook illustration, a big circle where you can help yourself identify the flavours you experience, with all these different colours shooting off. So when you hear Emily say that this tastes like grapefruit, well, she's using the technical language derived from World Coffee Research. Me, on the other hand, not so much.
It's completely different.
Isn't it? It's dramatically different.
That initial hit is quite sweet, so it still tastes quite fruity in that sense.
Yeah.
It's just the aftertaste is so drastically different from that Peruvian coffee.
This I find is quite sort of boozy. It's quite, fermented fruit. That's a lot to do with the processing method as well on it, and how, the natural process.
What does that mean, Emily?
So the natural process is the oldest method of coffee processing, and it takes 3 to 6 weeks to complete this process. So after the cherries have been harvested, they're laid out in a thin layer and they're dried in the sun. So this is either done on brick patios, or some of them use raised drying beds. These are really great because it gets circulation around the whole coffee cherry.
Fantastic. Yeah, really different.
Yeah. Because that fruit's in contact for such a long time, that's what gives it that boozy kind of fermented taste, yeah.
Literally everything seems to affect the flavour. Back over whilst we're roasting, Simon tells me that washing the bean, drying it, transporting it, especially grinding it, each little component tweaks and changes the final outcome of that cup of coffee.
So now what we're doing, Harry, is we're putting on the cooling drum. So we've got a rotating arm here. We're just about to drop the coffee out and going to cool it down. It's like a giant colander, and it's sucking air through this. So when the beans are dropped, they don't carry on roasting, so it cools them as fast as we can.
these variables that we've spoken about don't just affect the flavour though, they affect the composition of the coffee as well, and that includes its caffeine concentration. Before we go any further, it's back to Luigi at the Botanic Garden. He told me what role caffeine plays in the coffee plant.
So caffeine is present in a few parts of the plant and serves quite different purposes. One of them is to limit the pathogens that may attack the plant. Another one is actually to create a sort of mark for pollinators. So the caffeine is also present into the pollen nectar of the flower, and it sort of gives a memory for the insect that come to pollinate the flower to say, this is a coffee plant, come back. And another reason instead for caffeine production by the plant is to mediate a relationship with a fungus. And this fungus provides the plant with nutrients, but also limits other pathogens to attack the plant. And lastly, caffeine builds up in the soil through the leaf litter, and so caffeine almost acts as a poison into the soil to limit the germination of other plants. So it functions as a weapon for coffee plant to attack other plants.
Inside the human body, caffeine is readily absorbed and distributed. It affects several neural mechanisms, such as inhibiting adenosine receptors in the brain, responsible for promoting sleep. I asked James whether my thirsty father was getting too much caffeine in his 4 mugs of coffee a day.
It's a good question. When it comes to caffeine consumption, there are broad guidelines out there, and they'll say for an adult male, it's 300 milligrams of caffeine a day. The tricky bit is that you don't know how much caffeine is in the cup of coffee that you're drinking right now. You don't know how much coffee is in the raw coffee beans. You don't know how good a job you've done of getting the caffeine out of the beans. But I would say 4 cups of coffee, if it's good quality coffee, will take you around about 350 milligrams. Cheaper coffee has a higher caffeine content, so if it's 3 cups of instant coffee, you're probably there quite comfortably.
Caffeine has historically had it pretty bad in the press, but research suggests that moderate coffee consumption, anywhere between 2 to 5 cups a day, could be more healthful than harmful. There's been suggestion that it can lower the likelihood of type 2 diabetes, prevent heart disease, liver cancer, Parkinson's disease, and depression. I will say, though, these topics do remain hotly debated. But on the other hand, are there any negatives to drinking coffee?
I think that the primary issue is going to be sleep. And I think we understand more and more about the importance of sleep. The good quality sleep is essential for health in a way that I don't think we truly understood until relatively recently. So, if caffeine is interrupting your sleep, it really is a problem that has long-lasting and serious health effects. And I think it's definitely one to worry about. I think we've probably been a bit blasé historically about our consumption of caffeine and sort of tied it into feeling productive and getting the job done and all of that kind of stuff. So yes, I think that's the first big indicator. Different people genetically do deal with caffeine differently. So there are slow caffeine metabolizers and there are fast caffeine metabolizers. So the sort of half-life of caffeine in your body will vary based on your genetics, actually. So there's no single hard and fast rule.
There are subsections of the population that this rule doesn't really apply to. The story is a little different, for example, in pregnant women. For this cohort, there's a reduced recommended intake. It's less than 200 milligrams of caffeine a day. That's on average roughly 2 cups. That's because high caffeine consumption is associated with complications, including miscarriage and stillbirth. So maybe we should know how much caffeine differs between each mug of coffee we drink. With that in mind, I took it up with my friend Jonathan in the chemistry department at Cambridge University.
You've made me read up on this topic quite a lot, and I actually appreciate it because it's quite interesting once you get into the nitty-gritty of it. And it's interesting that in the year 2022, people still debate on how best to get the caffeine out of the coffee. So, very timely. We're very timely indeed.
Here's the plan. I have 3 samples of espresso, and hopefully we're going to see if there is a difference between brands in caffeine concentration. Now, if we were to do this to the highest standard, Jonathan says we would need hazardous chemicals and some pretty skilled expertise. I've managed to twist his arm and drop quite a lot of that scientific scrutiny, but bear in mind, he really did not give in willingly.
Okay, so the way we split these samples up is we'll make sample number 1 to be Hot Numbers, which is a local coffee shop, Sample number 2 will be a large-scale coffee chain, and sample number 3 will be another local coffee shop. And the first thing that we do is we will make a dilution of these, because the coffees are quite dark in color and we want them to be as translucent as we can, these solutions, in order to get our light through them eventually.
We're using a pretty fancy bit of kit. It's UV spectrometer, have I got that right?
Yeah.
And what does a UV spectrometer do?
So with this, we can basically shine some light through a liquid, and we can see at what wavelength of light the particles in this liquid absorb or emit.
Right, and I'm assuming that the more of this molecule, in our case caffeine, there is, the more...
the bigger the absorbance of light will be at that wavelength, yes.
And we'll see that on this computer here.
Yes, that will look like a peak, basically, like a mountain, right?
In goes sample 1, sample 2, and finally sample 3. In fact, I've told a bit of a white lie, because we actually did run a lot more tests, mainly because Jonathan was attempting to refine our results. By the end, though, we were left with 3 graphs representing our 3 espressos.
So with samples 1 and 3, we see generally that they show higher levels of absorbance at the wavelength that we would expect caffeine to absorb at.
And then with sample 2, what do we see?
So sample 2 shows a lower general absorbance at that specific wavelength, which could suggest that there's less caffeine in that sample than the other 2.
And from the data that we've got, it's not perfect by any stretch of the imagination, but we have an absorbance of 0.4 for sample 2, and for samples 1 and 3, it's 1.4 and 1.5 respectively. So it's times 3 bigger, maybe times 4 bigger almost.
So sample number 2 came from a big chain coffee house, whereas samples number 1 and 3 were from local coffee shops.
Now, our experiment isn't precise. It would probably start a brawl over a peer-reviewed journal. And that's because we didn't extract the rest of the gubbins from the coffee due to us needing those dodgy chemicals. See, when the light shines through our sample, it is possible that some of the rubbish left behind in the coffee is absorbed at the same wavelength as caffeine. In short, we need to take our results with a large pinch of salt. But our results do make sense, as James explains.
Historically, you've seen a bunch of studies done on the British high street, coffees from all the major chains, and really quite broad caffeine levels found in those drinks, big variations, relatively low to really surprisingly high. So because caffeine is not a simple thing, it exists in nature primarily as an insect repellent. And so the higher you grow coffee, the less need there is for the plant to produce caffeine. And so unless you know the altitude that your coffee was grown at, it's hard to make a very good guess at the caffeine content. Different species produce different caffeine contents. And then in the brew process, caffeine's highly water soluble, but if you don't do a great job brewing the coffee, you won't actually get all the caffeine out. If you do an incredible job brewing the coffee, you'll get a little bit more. So all of these things kind of come together into pretty large variations for the kind of consumer experience.
Historically, the coffee industry has been really opposed to putting caffeine measurements on their products. In part, it must be somewhat down to the difficulty when trying to extract caffeine. And it also must have something to do with the massive variation between each batch of coffee beans. I think it's pretty fair to say that we haven't got a clue how much caffeine is actually in there. And maybe we should know. It does seem particularly important for some members of the population, like pregnant women. You're listening to The Naked Scientist with me, Harry Lewis, and we're chatting shop, coffee shop. Now, we've seen how the drink has exploded onto the supermarket shelf and high street, but it looks like this tasty stimulant's growth may be a thing of the past. In fact, it might become somewhat of a rarity. That's because our 2 favourite species of coffee are likely to fall victim to climate change. Dr. Roman Gruter from the Zurich University of Applied Sciences recently published work in PLOS outlining the expected suitability of coffee in the near future.
The biggest producers of Arabica, I think, is Brazil, but also several countries in South America. I think the limits today are about 27 degrees north and south the equator. So you can find it really in many places in India, Eastern Africa, but also in Southeast Asia.
What does the future of Arabica look like over the next 20, 30 years?
So what we found in our study was that Arabica coffee might be negatively affected by climate change. I mean, it's very difficult to say when and where it might not be possible to grow coffee Arabica anymore. But what we could clearly find in our study is that we have to expect a decrease of suitable areas for growing Arabica globally in the range of 30 to 60% by 2050. So this is quite a drastic decrease. However, I have to stress here that there is also possibilities for climate change adaptation in these coffee agroecosystems, which might have the potential to partially offset some of these negative changes.
Right, and would I be right in thinking that as the temperature changes, it's obviously happening all over the globe, so some areas might become less suitable for growing coffee, but that means that some areas might become more suitable for growing coffee that you couldn't previously do it before?
Exactly. This is also the other extreme that we could find in our study. So there are certain areas that might become more suitable for growing Arabica, mainly at higher altitudes and latitudes. But compared to the areas decreasing, this is a much smaller area of land that might become better suitable for coffee.
I mean, is this something you're quite worried about? You know, is this something that you feel is pretty inevitable?
Yes, I am worried about this, and maybe not about the fact that it might get more expensive to drink coffee in the future, or coffee might get less available. But I'm more worried about the fact that a big number of smallholder farmers who are really depending on selling this crop, they really get under pressure, and they need alternatives, alternative crops, ideally that can still be grown in their agricultural systems, but also they need support for adaptation strategies, let's say by the state or by organizations working in this field.
Yeah, coffee's future appears pretty bleak. And that's in the words of someone who has travelled the world to document it. Dr. Aaron Davis, the Senior Research Leader of Crops and Global Change at Kew Gardens.
Unlike many of the things that we either eat or drink, coffee is a perennial crop. It's a tree crop. It has to be in the ground for many, many years. It's not like an annual crop like rice or wheat where you can simply replant every year. If your crop is destroyed, let's say by drought, then you have to replant, and it takes 4 to 5 years to get your crop back. And that's a huge issue for all farmers, particularly smallholder farmers.
Aaron says that farmers find themselves in this position could be encouraged to move to new locations where the conditions are more favourable, alter their practices, or try out a new species of coffee.
All three scenarios require effort and investment. However, unless we do something about greenhouse gas emissions, none of those adaptation pathways will make any difference. Our main focus is changing the coffee crop itself. So we don't want farmers to shift from coffee to another crop, because that also creates difficulties. So if you, as you've said, if you look at the coffee species that we drink two, Robusta and Arabica. However, there are another 128 coffee species out there in the wild. And what we're doing is we're looking at some key candidates that can be used to develop climate adapted crops rather quickly, because we don't have a lot of time. That's the other aspect to all this.
What are those coffees, and what are their attributes that give them that potential?
So we are looking at coffees that have market potential. When I say market potential, what I mean is coffees that are acceptable and desirable to consumers. What we've seen in the past are the production of coffees that were very good in terms of their farming attributes, high yield, disease resistance, etc. But the consumers didn't want to buy them because they didn't taste very good. In fact, some of them tasted quite awful. So we're learning from those mistakes of history in that respect to find something that really satisfies consumer demand.
What were those species called?
So at the moment we're looking at two species in detail. One of those is Stenophylla coffee. That's from West Africa. That's a really interesting species because it has what we might say a superior flavour. It tastes like high quality Arabica. The other main attribute is that it's extremely heat tolerant. It will crop and yield successfully at temperatures that are around 6 to nearly 7 degrees Celsius higher than Arabica. That's the average mean temperature. The downside with Stenophylla is it's a low yielder. So we would work on that to try and improve yields, and that's exactly what we're doing at the moment. Now, sorry, I didn't mention the other species, which is Liberica coffee. And there we've got something that is heat tolerant, and it may be somewhat drought tolerant. We're doing those investigations right now. But what it does have is an extremely high yield, and farmers really like growing it.
And Aaron, you said you're off on what sounds a little bit like not to sensationalise it, but an Indiana Jones expedition for coffee. I mean, what does that entail? Is that literally dropping yourself where you think there's going to be a new species or an old species that might fit the bill, hoping you find something?
It's a bit more structured than that. I mean, in the past, I've been doing this for over 20 years. We were really just going to all the unexplored places in Africa and Madagascar, trying to understand how many species of coffee there were and what the diversity was like, in the wild. Now we're more focused. We're going to specific places, looking for specific species with particular attributes that we think could be used for crop development. And we are looking for shortcuts. We're looking at the long game, but we're also trying to get things into the supply chain as quickly as possible.
I mean, are there examples of places where this is becoming commercially viable? Is this something where these two species that you've spoken of realistically could take off?
Yeah, look, we're working with Clifton Coffee over in Bristol, and we're about to import a large volume of Liberica from Uganda, and that will go into the supply chain this year. In Sierra Leone, we're not that advanced. We're just at the planting stage. So in Sierra Leone, we only refound Stenophylla in the end of 2018, 2019. So we've been building up stock. This year, the planting will start, and then within 4 years, we'll see the first crops. And the idea is to get it, into to shops and cafes, but also, perhaps more importantly, is to provide an improved coffee income for farmers in Sierra Leone.
When we started this journey, I expected that we'd talk about the loss of unique flavours. I sort of thought we were going to hear how breakfast routines would be ruined across the UK. And actually, what we've discussed is far more sinister. We've discovered that this is potentially devastating for the global south. Aaron told me that over 100 million people rely on its production worldwide. And if we're going to put in adaptation strategies, much like some popular brands of coffee, their implementation is going to have to be almost, instant. That's it for hot beverages this week, but we still have a little science left for you. Something completely different. It's that part of the show where we help you answer those questions you've been daydreaming about. This week, Otis Kingsman tried to lend Tabor a hand.
Does potential energy have any mass? If I were to charge a phone battery, would it become heavier?
It's commonplace to describe batteries as full or empty depending on their charge. So surely it would make sense for them to get heavier, right? Dr. Israel Temprano from the University of Cambridge has a few things to say that will change our understanding of how it works.
So potential energy is a term in physics related to the distance that a certain mass has in any potential well. So this relates to how high an object is. So if you have an object that is standing very, very high and you let it go, it will start moving, and then it will trade its potential energy to kinetic energy. That's not how we store energy in batteries.
It turns out these are two very different questions, Tibor. The potential energy of objects held up doesn't give it any extra mass. But then, what happens when we charge a phone battery?
So the common batteries that we use in our everyday electronic devices in electric vehicles and such is what we call a lithium-ion battery. Lithium-ion batteries work by just moving lithium ions, which is positively charged lithium atoms, from one side of the battery to the other. AA and AAA batteries, they have a different architecture inside, but again, all you're doing is moving components from one side of the battery to the other.
As the ions move to the other side of the battery, electrons move out of the battery and into the phone, where it generates electricity, before going back into the battery, but on the opposite side.
In order to balance the charge, electrons have to follow these ions. And what we do is force these electrons to go outside of the battery. And this is why we call this type of battery a rocking chair, because we're just moving things from one side to the other. And it's this movement of electrons that we use to power our portable devices.
When we charge a battery, we are moving the electrons out of the device and into a wire, before new electrons go back in on the original side of the battery that it started on. This resets the battery, and the process can start all over again. Overall, there will always be the same amount of electrons and ions within the battery.
So, no, when you charge one of these batteries, all you're doing is moving components from one part of the battery to a different part of the battery.
Thank you to Dr. Israel Temprano for helping us find the answer. Next week, we'll be finding the answer to this head spinner from listener Linda.
Can the spinning of the Earth be used as a source of electricity similar to the spinning of wind turbines?
And that's it for this week on The Naked Scientists. Don't worry, we'll be back. Next week, is your smart device listening in on you? I mean, this is a topic that we've all got an opinion on, I'm pretty sure. We'll be getting to the bottom of it and also looking at the science behind other modern marketing and advertising. What tools and tricks are being used to lure you in and spend that hard-earned cash? The Naked Scientists come to you from the Institute for Continuing Education at the University of Cambridge, and it's supported by Rolls-Royce. I'm Harry Lewis, and from all of us here at the Naked Scientists team, thank you for listening, and goodbye.